right, let's get started. I know that a lot of you, probably all of you, have heard about the murder of Chinwei Gao Monday. You may not know he was a student in this class. Those of you that were in 1030 last year, he was in that class as well. After the murder was in the news, I received email from TAs that had known him and also from students. And I was trying to figure out what to say today, and there was one TA that wrote something that I think sums up the way a lot of us are feeling. So I just want to read that to you. So it says, I remember grading his assignment yesterday. He is a nice and smart person. It's so heartbreaking to hear this. I pray that his soul rests in peace and to give strength for his family to overcome their huge loss. I have a few folks here from various places on campus. This is Allison Frost from the Office of the Dean of Students. And then we have the two gentlemen from the Counseling Center. They have a few things to say.
I'm going to come over there.
You can.
Sorry. So as you mentioned, my name is Allison Frost. I'm from the Office of the Dean of Students. And we wanted to come connect with the students that were in classes with Chen, and recognizing that there are varying levels of association. Maybe you've never met him, but also recognizing that this impacts the entire campus in a devastating way. So we wanted to let you know about resources. We can say over and over what the resources are, but once you're overwhelmed or impacted by things like this, sometimes it's hard to really navigate or ask any questions or know when to ask for help. So part of what my office seeks to do is to support students, help ensure that they know the rights and options that they have as they're navigating extenuating circumstances. We sometimes help facilitate conversations with instructors. I know sometimes that can be intimidating and vulnerable to say, I'm really struggling, or I've been overwhelmed with emotion, and having to recount why you're navigating that. So sometimes we help figure out what options are available to support you so you can either stay in classes. Sometimes students need to withdraw from classes because they need to focus on getting well themselves, so we can help with those things. A lot of times it's just directing on where to go for different resources. So please know that our office is open. We're in the Union Building in room 270. We can also help work with, even though you had this class together and we're coming to this class, we know you also likely have other courses that may be impacted academically as well. So please know that we are available. Come talk to us. I left some cards here if any of you need them, but even if you don't get that, feel free to walk in anytime or call our office and we can see how we can help you.
Hi, I'm Josh Goodman. I'm an intern at the University Counseling Center, and I want to take a couple moments to just talk about reactions to grief that you might be having. And Dr. Steve Lucero is passing out some handouts as well about resources and other types of reactions. But what I want to share with you is that you might experience any of a really range of reactions, and that whatever you're experiencing is normal. So it's going to vary from person to person, but people might experience anything ranging from sadness to anger to just feeling overwhelmed or numb to having new perspectives about the fragility of life and things like that. And all of those are really normal reactions. And one thing that can sometimes happen too is people might feel that their reaction isn't normal or isn't right, but there's really not a right or wrong way to react. It's okay if your reaction is different than other people's, and it's okay if you for instance find that it's been a couple weeks and you're still feeling really sad and upset, and it's also all right if you notice that maybe you're affected in ways that are different than other people, or for instance, sometimes people have felt guilty for not feeling overwhelmed or upset, and really, everybody sort of processes it differently. And so I just want to encourage you to, accept or be okay with whatever reaction you need to have. Take time to take care of that reaction and acknowledge it and get the help and support you need from the community you have here at the university, and certainly from others in your life, and at the University Counseling Center as well, if that's a resource you would like to use. We're certainly here for you. And Dr. Steve Lucero will speak next.
Yeah, we just wanted to let you all know that as a result of everything going on campus right now, we set up some special drop-in hours, and so we're in the Student Services building. We have a new mindfulness center that we started that's on the 3rd floor, and so anytime between 9 and 3:30 in these next couple days, we're going to have a counselor available to be able to just drop in, check in. It could be about sort of your reactions to Chen, it could be about other things happening in your life, but just know that we have extra services available right now. In addition, anytime during the work week, Monday through Friday, 8 to 5, we always have a crisis counselor available. And you can see that person for a variety of concerns, from having recently lost someone to being acutely in distress. One thing that I think is really important to know, that if you're sent over by a faculty or staff, and we definitely encourage you to share this with some of your colleagues in the department and whoever you feel would be relevant. If you indicate to our front desk staff that a faculty or staff, some employee of the University of Utah sent you to our office, we'll make sure that you're seen as soon as we can get you in that day. So this way, you know that there's always an option to be able to come in and see somebody right away. We do offer everything from individual therapy to sort of acute crisis services, couples therapy, group therapy. We offer a number of sort of workshops and outreaches like this, where if you're part of a student group or other organization that wants us to come talk with that group or that organization, that student club, we're happy to do that as well. So our phone number is at the top of that sheet that I handed out, 801-581-6826. And sometimes I find that it makes it a little bit easier after having maybe associated a name and a face with the counseling center to be able to come in. And so now you know Josh and you know myself. And so I definitely want to encourage you that whether it's related to something that's happening right now, or your reaction to Chen, or even just something going on in other areas of your life, I definitely want to encourage you, or if you want to sort of encourage a friend to come in as well, we'll do whatever we can to offer that support. So before we go, I'm curious if anybody has any questions that we might be able to answer for everyone at this point, whether it's about Chen, the Counseling Center services, something that maybe the Office for the Dean of Students might be able to help out with. Well, thank you so much for letting us come to address you all. And Josh and I are actually going to just hang outside for just a few minutes. This way, if anybody wanted to check in real quickly or briefly, or had a quick question that they wanted to ask, that you can do that as class is getting started. Otherwise, by all means, we want to encourage you to come over to the Student Services building. We're on the 3rd and 4th floor of the Counseling Center, and so we want to be able to help you out in whatever way we can. So thanks again.
Okay, so sort of lost a day there with classes canceled. The lab concerned recursion, and I thought about postponing it to next week, but it would be kind of too late then. So I'm going to just leave it online, and what I'm going to do is I'm going to associate it with a very simple quiz. It won't be taxing at all, I promise. So just do look at the lab when you get a chance before you start the next assignment, and just fill in the quiz, which will be more of a questionnaire to get credit. Okay? And then I'm going to extend the deadline until Friday on the assignment. We're adding TAs to the Friday schedule because I figured there'd be more people than usual. You can use a late day to hand it in Saturday. If you need more time than that, just let me know, and we'll work something out. Yeah?
So what's the deadline on getting the lab done?
I guess the deadline for getting the lab done, I don't know, probably like Wednesday of next week or something. it won't do you any good to do it unless you do it before you start the assignment, basically. So, any other questions? Yeah. It's available. The lab is available in the schedule. There's not the questionnaire isn't there yet. A little quiz. I'll add that after class. Okay. Now I've got to switch views here. That's what I want. All right, so we're talking about recursion. And the kind of recursion that we were doing on Monday is called structural recursion. And the reason is that structural recursion is how you consume a recursive data structure. So you think about it, we were working with what's the word? Not family tree, pedigree. Family of pedigree that showed a person and their descendants, or their ancestors. And the way it's defined is a pedigree tree is either null or it's information about a person with references to two pedigree trees. So pedigree trees are defined in terms of simple pedigree trees. Therefore, it's not surprising that when you write a method that consumes a pedigree tree, it has two cases. Either the pedigree tree is null or it's not. And typically has two recursive calls, one to deal with the father's pedigree tree and one to deal with the mother's pedigree tree. And we'll see more examples today of structural recursion. This is the first one here. So this is called a Sierpinski Triangle. And this one here is particularly simple. It's just a red triangle. And I'll call this a level 0 Sierpinski Triangle. So very simple. This is a level 1 Sierpinski Triangle. And I'm just going to go through the levels now. That's level 1. Here's level 2. Level 3. Level 4. Level 5. Level 6. 7. 8. 9. And 10. And it looks like it's getting dimmer and dimmer. But what's actually happening is there are more and more little triangles that you probably can't resolve. You definitely can't resolve on this projector. So what I want to consider is, how would you write a method? I have a method that's drawing the triangle, just using calls to the, drawing calls to the graphics object. It looks like it'd be pretty complicated to draw such a complicated shape up there, that fractal up there. But it turns out it's pretty simple to draw if you draw it recursively. So let's see how we can think of this as a recursive problem, or how we can view the definition of a Sierpinski triangle recursively. Okay? Looks like you want to ask a question.
So is it like, are the number of triangles multiplying by 2?
Well, he asked, are the number of triangles multiplying by 2? Well, let's see. So a level 0 Sierpinski triangle is just a triangle. Okay? How would you define a level 1 Sierpinski triangle? Say what?
3 triangles?
Okay. So there are a couple ways to look at it. One would be you take a level 0 triangle and cut out the middle triangle, a triangle in the middle. Or another way is you have a triangular region in mind and you place on it 3 level 0 Sierpinski triangles. And that's the way I want to think about it. So a level 1 Sierpinski triangle is a triangular area that contains 3 level 0 Sierpinski triangles. And the way they're arranged is, this point here is the midpoint of this line of the triangle. This point here is the midpoint of this line, and so forth. So we put a triangle down here, a triangle up here, and a triangle down there. And you got the blank stuff left in the middle showing through. So we've defined a level 1 triangle. I'll stop saying Sierpinski now. I'll just say a level 1 triangle in terms of 3 level 0 triangles. So that's a recursive definition. Here's level 2. Now, how could you describe a level 2 Sierpinski triangle? Yeah?
3 level 1 triangles?
Right, it's the same idea. This here is a level 1 Sierpinski triangle. It's smaller, but it's, there's a level 1. What you're seeing there are 3 level 1 triangles. So in all these cases, when you want to draw a triangle, you've got, the big triangle you're trying to fill in. So if someone asks you to draw a level 2 Sierpinski triangle, you would just draw, in the space provided, 3 level 1 triangles. Each of them, if I take this triangle here, this level 1 triangle, contains 3 level 1 triangles, 3 level 0 triangles. It's smaller than before. And we go up to level 4, or level 3, you see the same thing. We have 3 level 2 Sierpinski triangles in the space. And that's all that's going on as we go up. Level 4 contains 2 level 3s. Level 5 contains 2 level 4s. And on and on. And, gradually, pixels are disappearing because there's more and more white space. That's why it looks like it's getting dimmer. So that's the deal. So let me see if you have any questions about how this is defined. That essentially a level n plus 1 Sierpinski triangle is drawn by drawing 3 level n Sierpinski triangles. Yeah?
So would the parameter of it be like a level triangle?
Okay, so your method, so what he asked about the parameter to it. If you imagine a method called draw triangle, it would need to take its parameter, the level, right? So you'd say draw a triangle, draw a Sierpinski triangle at this level, level 0, 1, 2, 3, or 4. What else would that method have to take as a parameter? Okay, you somehow got to describe the space. So if someone says, draw me a level 10 Sierpinski triangle, in addition to the level, which is 10, we would have to tell them the coordinate of this vertex, the xy coordinate of that vertex, the xy coordinate of this vertex, the xy coordinate of that vertex. So we'd have to give them the coordinates of the 3 vertices that we want them to draw the triangle in. And we'd also have to give them, since we're talking about Java, a graphics object to draw it on. So those are all the parameters. So it'd be a graphics object, a level, and then 3 coordinates where the triangle needs to be drawn. Yeah?
So say, for example, when you draw a level 10 triangle, does that mean that the method has to calculate a level 9 and a level 8 and so on?
Okay, so he's saying if we try to draw a level 10, does that mean the method has to calculate a level 9, a level 8, and so on? Yes. But the way to think about it is, to draw a level 10 triangle, you make 3 calls to draw a triangle, except you tell it to draw level 9 triangles. The way to think about it is, to draw a level 10, you draw 3 level 9s in the right place. Rather than trying to think, okay, I got to draw 3 9s, and that means I got to draw 9 8s, and that means 27 7s, and that means 81 6s. You lose your mind trying to do that. So you simplify it. You just think, okay, to draw a level 10, I draw 3 level 9s.
So would that recursion call be like the method 3 times with whatever the level is minus 1?
Okay, so yeah, he's asking about the structure of the call, and whatever, if the parameter if your parameter is 10, you would pass 9 in the 3 recursive calls that you make to draw. So let's look at the actual code that's doing the drawing. There's a lot of other code that's handling the user interface, but this is Sierpinski.java actually does the drawing. All right, so what you see here, let's look at the parameters. Let me rearrange it so it's all on the screen. We pass in the level. That has to be non-negative, so 0 or bigger. We pass in the graphics object to draw it on. Actually, in this case, it's a graphics 2D object, which allows higher precision, which, when you get up these high levels, the round-off error will kill you if you're using integers, so it uses doubles as coordinates. X1, Y1 are the X and Y coordinates of one of the corners. X2, Y2 is the XY coordinate of the second corner, and X3, Y3 are the third corner. So just 3 vertices of the triangle. So it's telling you the extent of the triangle to draw. So what's going on here? If I say if level equals 0,
That's like if it's just Z.
Okay, that's just saying if I'm supposed to draw a level 0 triangle, then I just draw a single solid triangle in the space provided. That's what level 0 is. And you'll see that's what it does. It's using something called a path. But it creates a path that starts you start at x1, y1, and then you draw a line to x2, y2, and then you draw a line to x3, y3, and then implicitly you're drawing a line back to the beginning, and you fill that region. That's just a way of drawing a bunch of straight lines that define a region and then filling them with a color. So we just fill the triangle. Right? So that's what we call the base case. Non-recursive, yeah.
So it's possible to draw a triangle where it's not equilateral? So the Sierpinski...
Oh yeah, it doesn't have to be equilateral, and we could go back. Am I running it now? I don't remember. Yeah. So I can resize this window. It's just using when it makes the call to draw a triangle, it's using sort of the bottom left corner of the window, the bottom right corner, and the midpoint of the top. So I can squish it down all I want. I can change colors too. Might as well demonstrate that. Okay? So here we are.
Joe.
Oh, yes.
What is it in your code that's limiting it to a level 10?
Well, there's nothing in this code that limits it to level 10. It's just that my user interface only provides options 0 to 10. And so my program never calls this anything bigger than 10. It could. The problem is, this is a 4K display, so it has lots of pixels. That ain't. And you get above level 10, it just gets dim. It doesn't. You just can't see enough detail with that projector, or even with this display. Okay, so the base case is the word we use. When you have a recursive method, typically there is at least one base case, which is non-recursive. That's just solving the simple version of the problem, level 0. And then, after the else here, we have the recursive case. And what we were saying before I showed you the code was we have to draw 3 Sierpinski triangles, each of level -1, so one level lower than the one we've been asked to draw. And then, what's going on with all this arithmetic with x1 and y1 and so on? Yeah?
Well, we figure out how to position our smaller subtriangles based on midpoints. Those are calculating midpoints based on the...
Right. So, if we want to draw this level 10, we've got to tell it to draw 3 level 9s. We've got to tell it where. And so, like down here, say this is x1, y1. That's one corner. Then we'd have to figure out the midpoint of this line right here. That's going to be the average of x1 and x2, and the average of y1 and y2. So we calculate that midpoint, we calculate this midpoint, and that gives us the corner of one of the triangles. So all we're doing with this code here is calculating midpoints. So we got one that starts at one vertex of the original triangle and then goes to midpoints. One that starts at the second vertex, one at the third vertex. So that's the calculating that decides where things are being drawn. Okay? So, yeah?
How would you handle negative levels?
He said, how would we handle negative levels? We can't, because Sierpinski triangles aren't defined for negative numbers. And so I really ought to have up here that level has to be greater than or equal to 0. If we're really worried about it, we would we could put code that throws an exception or something. Or we could say if level is less than or equal to 0, just to catch that case. But, yeah. Any other questions? Yeah. Start with you.
I'm not understanding why it wouldn't fill in only one triangle, because wouldn't it go down to the base case and then fill in that one triangle and then return that?
Okay, he's saying why does it draw more than one triangle? Well, let's do this. Let's comment out these 2 calls. So we'll only draw one triangle instead of the 3 we're supposed to. So what's it going to look like? Anyone want to predict what it's going to look like? Yeah?
So the only one is in the top, x1. So
Yeah, I'm not sure if x1 is the top or the bottom left.
Yeah, only one close to x1.
Okay, so only one of the triangles will be filled out, but that triangle won't be a Sierpinski triangle, will it? Okay, let's go back here. You may be thinking, let's say for the sake of your argument, I don't know what x1, y1 is. I'm going to say that this is x1, y1 down here. So you would think you might just see this triangle here, and this would all be white space. But is that right? Will you see this triangle? This triangle will not have this part filled in or this part filled in either, because it's using the same code to draw the level 9 triangle. So it's going to look quite a bit different. Let me show you. So there's level, let me enlarge it a bit. So there's level 0. Yeah, I was wrong. The x1, y1 is the top. So we just get the top filled in, and we keep going. And it's not very interesting at all. Here's level 10. So you see,
I see it.
Can you see it?
Barely, it's a dot.
Yeah, I can see a dot here too. You know, you start to see it now. So you see, changing that bit of code didn't just mean the level 10 only contains one level 9. It means that level 9 only contained one level 8. And that level 8, now we can do this. How can we make it so that you end up with, that a level 10 consists of just that one triangle? That one level 9, but the level 9 drawn completely. Yeah?
Triangle dot line 2 and triangle dot line C2.
Well, I don't want to mess with that, the thing that draws a triangle. What I was after is this.
Yep.
If level is less than 10, then do this. So I'm going to draw if it's level 10, I'll draw just one triangle. If it's level 9 or below, I'll draw both. I'll draw all three. So now let's run it. So there's level 0 rather. There's level 1. All is normal. Here's level 9. And then what's level 10 going to look like? It'll just have the very top, but in all of its detail, not just the pixel. Now, it's interesting to note, this thing is just made up of, we saw one of the dots that gets drawn at level 10 before. This is just a bunch of those dots. I mean, by themselves, they're insignificant, but I guess that's obvious. It's always going to be dots. It's just pixels. Okay? So I hope you see the difference between this just sort of disabled level 10 from doing the right thing. When we just commented out those calls, though, it disabled the correct behavior on all levels and completely changed what you see. Now let me ask you this question. Where in this program is any triangle drawn at all? Just the base case. That's the only time. Only when you ask a level 0 that a level 0 triangle be drawn is anything inked on the screen. Okay? So that means what this program is doing. What's another way to think about what this program is doing in that sense? What's a way to describe what my program is doing? Yeah.
It's just drawing a lot of level 0 triangles.
It's drawing a lot of triangles all over the screen. Now suppose that had been your assignment. Suppose I said, write a method that draws, by drawing little triangles all over the screen, produces that pattern. That would have been a pretty hard job, even if I gave you the pattern to start with. So if I describe a triangle that way, that's not very helpful. The program would be immensely complicated. On the other hand, if I say a level 10 triangle is just 3 level 9 triangles arranged in a certain fashion, and so on, suddenly it's just a few lines of code to draw. So it sort of conquers the complexity. What would happen if I commented this out? Even though I just changed the base case, I didn't change the recursive case at all, now it doesn't matter what level we're on. Nothing is drawn. It's still going through all these method calls, trying to draw things, but it gets down and tries to draw a little tiny level 0 triangle in the right spot, and it doesn't because I commented out the fill. So ultimately, all the recursive cases ultimately depend on the base case. they get reduced to the base case. How many times do you think the base case right here is executed? Well, let's find out. I don't think it has to be long, but I'll declare it long anyway. I'm going to declare a variable called count. And every time we draw the base case, I'm going to increment count. And then after the method ends, no, how am I going to do this? This is going to print out a lot of counts. I was trying to think how to get it to print. I'd have to go change a different part of the program to print out count after the whole thing has been displayed. So I'm just going to print out count every time this thing is called. So let's run it. And you can see it print out a 1 because it just drew one triangle. Let's draw.
You got to find it outside the method.
Okay, so I made a mistake. The problem is it's a local variable to the method, and it's reset to 0 every time a method call is made. So I need to create a static. This is what static methods are for. Static data, static. I don't think it actually needs to be static. Yeah, it does, because this is static. So the static method needs a static variable to access. And so when it increments count now, it'll increment the class variable count. That doesn't go away every time we call the method. So we've got one variable in the class for this to work with. I said 99.9% of the time you don't want to use static variables in a class, non-constant. This is the 0.1%. All right, let's try it again. Okay, so we did 1, 2, 3, 4 that time. So it did 4. What did it do 4? Oh.
Count isn't resetting.
Not resetting count to 0 each time. Oh well. So let me start it fresh and just do, okay, so it's 1 and then we're going to do 10. Okay, so it did 59,049, not counting the one that we had before, calls to the base case. So we drew that many little triangles to draw the level 10 thing. All right. Now, I'm doing this partly to amuse you. I'm doing it partly to help you understand recursion a little better. So you can see that, this simple looking method right here is producing what looks, pretty complicated looking results. But we can understand this code. All right. Any other experiments anyone would like me to try, or questions you'd like to ask? Yeah.
Why did you put level as less than or equal to 0? Why didn't you just put equal?
I had it equal to 0 before, and someone asked what happens if the parameter is negative. So I decided to fix it that way. Yeah.
What does the path 2D object do?
Path 2D is just a way, so you've been using sort of, when you do graphics, I've been having you use a version of graphics where everything is an integer. Every coordinate you use is an integer. And for this purpose, integers aren't good enough when we get to high resolution. We need to use doubles. And some of the methods are different in a graphics 2D object. A path object just describes a closed path formed from lines. So we create a closed path here, and then we fill the interior of the path. I guess a closed path is a region. It's a way of defining a region. Yeah?
So you commented out the bottom two in the else statement before. What if you comment out like a different set of them, like say the first one, and keep this up?
Okay, so what if I comment that one out? What is it going to look like? I'm going to comment out this print line too, because that takes longer than the graphics. How's it going to look? Anybody want to hazard a guess? It's a little hard to predict. I always predict wrong. What's that? Well, notice last time I commented out two things. I commented out the last two. Now I'm just commenting out one thing. So it's not going to be It's going to be more than a single triangle.
So is it just gonna be a bunch of separated bottom line?
Yeah, I don't know. Got an idea?
It's just gonna be the bottom two, except all the ones inside that also will. It's hard
Yeah.
to describe the shape, but
Right, every triangle at every level will just have the bottom two triangles, but how will that look? I think we can understand at a micro level what's going to happen. It's predicting, just like, what if I ask you to predict, not having shown you that diagram before, what this would look like? Right? It would be hard to imagine that fractal. So I think, I don't know, I've done this before, but it's been a while, so I don't remember what it's going to look like. So let's look. We'll go to level 2, level 1 now. All right, so you're getting, and again, we go to level 10. Now, you sort of see a sea of dots. Right? So, you know, Sierpinski obviously wanted to attach his name to something more interesting than that. So that's why he makes the 3 recursive calls. Yeah.
So how would you debug something like this? Because if you're calling the recursive thing multiple times.
Okay, so it's asking about debugging this, or I assume just recursive methods in general. And it can be tough. Because these methods get called, you end up with 50,000 calls to the base case. So if you put a breakpoint in there, it's going to hit the breakpoint 50,000 times. And if you're looking for one combination of values, you're going to be looking a long time. That's where a conditional breakpoint can come in handy. So conditional breakpoint, if you right-click on a breakpoint, you can set its properties. And one, you can enter a condition, and the breakpoint will only be executed when that condition is true. So you could say something, the condition is only executed if x1 and y1 are really close together or something. Like anything else, it takes practice. Yeah?
So I'm a little confused about recursion in general. So like when you have the else statement and you have the 3 draw Sierpinski triangle calls, how is it drawing, like I understand that it's changing the parameters, but like how is it drawing anything if you have the if level is less than or equal to 0? Like if you have something that's like level 10, like how is it running that if it's level equal to 0?
Okay, well, let's do this. I'm going to set a breakpoint right there. So every time this method is called, we're going to break. All right, so I'm going to run in debug mode. And here we are. I'll try to make this a little bit bigger because this is really the important part. I didn't want to make that bigger. Maybe. Okay, so right here, it's hard to see, but it says we're at draw triangle, line 17. You see it right there. And right now, level is 0. Okay, so that makes perfect sense. So let's resume executing, and that's all. Now, I need to get 2 things visible at the same time. Now let's go to level 10. Well, let's do level 1. Suppose I draw level 1. All right? So I'm at level 1. I'm going to resume. What's going to happen next? So I've entered the method for the first time. When will I hit the breakpoint again? When will draw Sierpinski be called again? Maybe I should show you the code. So right now I'm right here on the highlighted line. We're not at level 0, so it's going to call draw Sierpinski 3 times. So when we hit the breakpoint again, we're now at level 0. And that's going to go through and actually do some drawing.
Wait, how are you? I thought you chose level 1.
What's that?
I thought you were at level 1.
I was at level? Okay, let me start again here. Also, another problem is that it's not displaying the update to the screen until the graphics object's been updated. So we can't watch it get drawn in real time. Sorry about that. I wonder if I could arrange for it to be drawn. So we're gonna go do level 1 again. So right now we're at level 1. First thing we're going to do is call draw Sierpinski with a parameter of level 0. Okay? So let me do that. I'll resume. We hit the breakpoint. Level is 0. Okay? So it's going to do its thing. I'm going to resume again. We'll hit the breakpoint again, right? Again, level 0. Displaying a different triangle. We resume it again. We're still at level 0. That's the third triangle. And then if we resume, it's not going to hit the breakpoint again until we draw something else. Now, what would happen here if I went to level 10? So we're at level 10. Now we're at level 9, level 8, 7, 6, 5. You see the stack frames building up here. 4, 3, 2, 1, 0. So that's going to draw a little bit somewhere. Now, if I kept clicking, I could trace it through all the levels. But so far, we have just done, at the top level, level 10, we got to make 3 calls. We've made 1 of them. Level 9, 3 calls. We've only made 1 of them. Next level, we've only made 1 of them. So there are a lot still to come. I don't remember the original question, but that's my answer. What was your original question?
So that makes sense. It was just like how does it run if it's at a level that's higher than 0? But
Yeah.
so when you said it was going from like 10 to 9 to 8, what is it doing till that time until it elapses to 0 again? And then it comes.
Well, when you call it level 10, all it does is make it makes a call to draw Sierpinski with level equal to 9 and with the coordinates different. So nothing is drawn until you hit the base case.
So how does it
The difference is the parameters change. So at level 9, at level 10, level is 10, and x1, y1, x2, y2, x3, y3 or something.
Okay.
When you make those recursive calls, you're passing in a smaller triangle.
Okay.
Yeah.
So if you keep going, it's going to start going through that stack. So it'll draw like the 0 triangle, then it'll go to the 1 triangle, draw the 0 triangle to that 1.
Right.
2.
So yeah, if we keep going, you'll see it bounce back up to level 1. No, you won't see that. You'll see it. So right now, let's look and see what it's up to. At level 1, I can just click. This is the level 0 stack frame, the level 1, the level 2. At level 1, it's currently made that call to Sierpinski. If I resume it, then I'm at level 0. Back at level 1, we're in the process of making the second call. And it's going to stay at level 0.
3 times.
You can do this, but it's really easy to get confused with what's going on. Every time I try to set breakpoints and show students what's going on in the recursive method, it's really tough to track it in your head. So the best way to understand recursion is not try to think about what's going on when the program runs. It's just think about it mathematically. To draw a level 10 Sierpinski triangle, I draw 3 level 9s in the right spot. And to draw level 0, I just draw a triangle. That's what you need to know. Yeah?
Would it be like a similar coding structure to draw other types of recursive shapes? Like if I wanted to draw a Mandelbrot set, would it just be a similar code and then you have to define the level?
Yeah, Mandelbrot sets are a lot more complicated.
Yeah.
They're not so much defined recursively, they're defined in terms of infinite series and whether they diverge or not. When I say a lot more complicated, I think a lot more mathematically complicated. To write a program to actually draw the Mandelbrot set, is within your reach. Yeah.
This used to be an assignment that students have to do. Can you comment on the thought process of some students where they drew a big triangle and then they drew a white triangle on top of it, and then they drew a white triangle on top of those 3?
Well,
you want to comment on that?
Yeah, you did the grading, but I don't remember that. You want to comment on it?
It's just a different thought process.
They got to work that way?
When I explained it to you, you were like, wait, they're doing it wrong.
But it looked right?
It looked right, yeah. It worked completely
I guess
right.
you could draw, to draw level 1, you could draw...
Find the 3 midpoints and then draw a white triangle on top.
draw the red. So you could start with, so essentially, you imagine at the beginning drawing a big red triangle and then gradually eating away by drawing white triangles on top of it.
Right.
Yeah. You can think of it that way too. Maybe it's a better way. It's good when you got more than one simple way of looking at things, that often you get some ideas. Yeah?
Would that just be like a matter of memory usage? Like,
would what be a matter of memory usage?
This way versus that way that Stephanie was just explaining?
I'm not sure. I need to think about it a little bit harder than I've been able to. I don't want to answer that right now. Any other questions? Yeah?
Yeah, something that's not clear to me from the last class and also from the reading is like using a for loop versus using recursion. Like the way the book makes it sound is like if it's obvious, like there's certain things that you do that it's just like this should use recursion.
Okay.
But like, yeah.
Okay, so he's asking about how do you know to use recursion versus iteration? And my advice to you is you use recursion when the thing you're manipulating, in this case triangles or pedigree trees last time, is recursively defined. So if you've got some thing that you're manipulating that's defined recursively, so level 10, level K plus 1 Sierpinski triangles are defined in terms of level K Sierpinski triangles. And pedigree trees are defined in terms of simpler pedigree trees. When you've got that kind of structure in your data, it's natural to write a recursive method that consumes it. And so why is it completely natural? First of all, that we have two cases here, an if and an else. What determined that, if and else?
You're always drawing at level 0.
Yeah, well, because they're essentially, in the definition of Sierpinski triangles, there are two parts to the definition. Level 0 is just a triangle. Level 1 is level K plus 1 is 3 level K Sierpinski triangles. So you got the if else. And why are there 3 recursive calls in the else case? Because the level K plus 1 is defined in terms of 3 level Ks, which is defined in terms of 3 level K minus 1s. Similarly, with the pedigree tree, the recursive case, there were 2 recursive calls because a pedigree tree contains 2 pedigree trees. So we make a recursive call to deal with each one. All right, let's take a break and we'll look at something different. Okay, now I just had a question at the break, and I just want to emphasize that that's not it. When you work on the current assignment, to be sure you're doing the right thing. So let me see if I can find the right thing here. So you're working on PS8. PS8 starting point, source, rational, big red. Okay. You need to change this so that it's a big integer. You need to change this so it's a big integer. Right? You're using big integers now instead of longs. This stays long. You do not change the header of that constructor. You do not change the header of that constructor. You do not change the header of that constructor. You add a new constructor, a 4th constructor. That one takes big integers. Yeah?
Are you expecting us to change the Java doc comments on those methods?
Am I expecting you to change the Java doc comments? Well, let's see. No?
They don't have to add the 4th, you already added it.
Yeah, they don't. Yeah,
They just have to fill it up.
Right, the 4th one is there. You've got to implement it. Now, you're going to have to go change the implementation of this because this was written assuming that num and that these 2 variables right here were longs, and they're not anymore. So you have to change that. Do not change the headers of any of the constructors. Yeah?
Is that 4th constructor supposed to be an and instead of an or?
Which constructor?
Yes, that's a mistake. Go down to the 4th constructor. You have an R in there, big integer R, and it should be an N.
That is true. Yep. Yep.
Should we make another constructor for just the numerator being the big int? Like just a single?
He's asking, should you create a fifth constructor that takes a single numerator as a big integer? No. You may if you wish, but I would make it private. Yeah?
Are you going to take points off if we don't refactor that big integer r to an n like you just did?
No, that's okay. That's my mistake. So if you left it as, if you preserve my spelling mistake, that's okay. I don't take points off in assignments anyway. It's people like Stefan that take the points off. Don't blame that on me. Okay?
You always make me out to be the villain.
You will know you've done it right. These tests should continue to compile and work. Most of these tests just deal with those three original constructors. You shouldn't have to change anything about the test cases to get them to run. Now there's only one that I've added down here that actually tests a truly big integer. So you probably ought to add some more test cases along these lines. These other ones should still work without any alteration. If they don't, then if they don't compile because parameter types are wrong, you've made a change I didn't mean you to make. All right, I just want to make sure everyone understood that. All right, now let's look at one more example. Another example of recursion, and that is a file system. In what way is the file system on your computer the system of files and folders? Or the word Java uses, comes from Unix, is directories. So I'll use that. Directories, think folders, and files, think documents. How is that recursively defined? Yeah?
In this case, the files would probably be your base cases.
Okay.
And the folders can have more folders inside of them, so that would be the recursive part.
Okay. So if we try to describe what a file system is, it's either a file or it's a folder containing other parts of the file system. So a folder containing file system parts. So we sort of need a name for file or folder. I'll call it file system component. So a file system component is either a file, that's the base case, or it's a folder containing other file system components. So there's your recursion. And so as recursion shows up in the definition, it's a circular definition, if you will. And so the methods that consume file systems are necessarily or naturally recursive. Now, I just remembered I have a slide I want to show you that shows all this in pictures. So let's go find it. Okay, so here's what I'm talking about. As soon as that disappears there, I'm using that sort of funny looking rectangle with the edge bit out to stand for a directory or a folder. Oval is a file. And triangle stands for what I was just calling a file system component. Now, what Java calls it, very confusingly, Java calls that triangle thing, a file with a capital F. And then it also tries to distinguish between directories and files. So sometimes I'll say file with a capital F, that means directory or file. Sometimes I'll say file with a little f, that just means a file. Sorry about that. That's a picture of a typical file system. You know, we've got a folder up there called docs, a directory called docs that contains 3 directories. The CS1 directory contains an empty directory and a file with a little f, and so on. And we might want to ask questions about that. Like we might ask, how many files are there? Well, if we just count the ovals, there's files with a little f. There are 4 of them, but how would you calculate that? We'd have to write a recursive method to figure out that answer. Or we might ask, what's the biggest file? Or how deep can you go in that tree? Stuff like that. We're going to see how to answer questions like that. The problem is, if this is how you think of a file system, it's similar to looking at the level 10 Sierpinski triangle and trying to figure out how you would draw it. It's easier to think about it this way. Just think that there are two kinds of files with a capital F, two types of file system components. Either a file with little f, a document, or a folder containing other file system components. So they're just two possibilities. That top picture is the base case, the bottom picture is a recursive case. So how do you think methods that we write to deal with file systems will be structured? Yeah?
We'll have our if statement that tries to identify if it's the first kind of file, then within that if is whatever we want to do with that.
Okay.
Else, we call that method on.
Okay. So what he said is it'll be an if else, because there's a base case, which is the first thing up there. So if it's just a document, a file with a lowercase f, that's the base case. It doesn't contain other file system components. Else, we're dealing with a folder that contains other stuff. How many recursive calls do we need to make to consume the contents of the folder? You know, with the family thing, the pedigree, we had to make 2 recursive calls because there were 2 pedigrees. With the Sierpinski triangle, we made 3 recursive calls because there were 3 Sierpinski triangles in each higher level. How many things can be contained inside a folder? What's the fewest number of things that could be in a folder? 0. And what's the most that could be? Any number. So what we'll have to have in the else case is a loop that loops over all the things the folder contains and makes a recursive call inside the loop. So it'll be a recursive call inside of a loop. Right? So we're getting a slightly more complicated picture. So that's the structure we'll see. So Java, again, file with a capital F can either be a file or a folder. Base case, there's a method isFile. I really hate this about Java. Of course a file is a file, but that isFile method is think of that as isDocument or something. So it's either not a folder, or in the recursive case it is a folder. In that case, we loop through all the files. So f.getFiles returns an array of the contents of the folder. And then we make the recursive call on each thing in the folder. So that's our structure. Let's put the structure to use. Let's see what method we can implement. Let's just, okay, this says if FD, so file FD stands for file or directory. If FD is a file, returns 1. That's the base case. That's one thing. Otherwise, returns the number of files or directories that are contained, directly or indirectly, inside of FD. So just to be clear, back to my picture. Right here, what would the answer be? What should that method return if we feed it this file system? And ask it how many files/folders are there? I ran out of fingers. Does anyone have an answer? I know you can count. Come on. How many boxes and ovals are there up there? 12, right? So that's my method is just calculating. It will start at the root there. It's just to count everything in that tree. Okay? So, and in fact, what I'm going to do is I'll have it count everything in this workspace folder. I hope I have a workspace folder on this machine. Can I run this? We'll see. Okay, so what's the structure of this method, count files? We already decided. What can I start typing without even worrying too much about what the method's supposed to do?
Base case.
Right, I got to find out if fd.isFile, do something, else, do something else. Okay, well what should I do if fd happens to be a lowercase file, a document. You return 1. Why does it make sense to return 1, besides the fact that it says up there to return 1? Yeah?
Because it is only one file.
Right. If someone hands you a file and says, how many things are there in this file system, there's only one thing, the file. The file doesn't contain any other files or folders. So of course the answer is 1. Well, that's good. Now, otherwise, we need to do what? Yeah?
Oh, we have to create a loop to loop through.
Okay, we need a loop, okay? And what's the loop going to do?
It's gonna count the number of files in it.
Say again louder.
It's gonna count the number of files in it, so it's gonna accumulate an overall count.
Right, it's going to count the size of each thing the folder contains. Now, what kind of loop does that sound like? What's it going to do with the count of it? So to say the folder contains 3 things, and it counts how big each of the 3 things is. What's it going to do with those 3 counts?
Accumulation.
It's going to add them up. That's an accumulation loop. And then add 1 to account for the folder itself. Okay? So we need to write an accumulation loop. Well, we know how to do that. So I'm going to say int count equals 0. And then we got to iterate over everything. Rats. What's the method called? I don't do this often enough. Get files. Okay. So we go through. What is it completing it out?
I want you to do list files.
List files, I'm sorry. All right. What do we have to find out about each thing that's contained in the directory F, in the folder F? Yeah?
We need to see if they're files or folders.
Well, we don't have to see if it's files or folders. No, don't need to do that. What property do we have to discover? Yeah.
We need to count the files.
All right, we have to find out how many things it contains. Okay? Well, we got a method to do that. It's just called count files. In fact, I don't like that name so much. I'm just going to change it to count. Okay, so I need to count FD. What do I do with the number that comes back? Accumulation
F,
loop.
it's F.
F, thank you. And I decided I don't want to call this count 2 because that's going to confuse us. We'll call it total. Okay, so what do we do with the number that comes back when we call count?
Total.
Yep.
Total equals the total plus count F.
Right. So we count how many things are contained in F. We add that to total. Yeah.
Would you need to declare your enumeration variable outside of the method?
He's asking, do I need to declare total outside the method?
You want it set to 0 every time it falls?
Well, no, because what's the last thing I do here?
Oh.
It's an accumulation loop, so I return total.
Right, I see.
Except I add 1 to it because I need to count the folder itself in addition to the things it contains. Okay? So let's see if that makes sense. If someone hands you a folder, you're going to say there's 1 thing in it. If someone sends you a document, you're going to say there's 1 thing. If someone hands you a folder, as in this picture here, someone hands you this folder, what you're going to do is you're going to count CS1, and that's going to be, what's going to get back when you count it? 3. You count this, you get back 1. You'll count this, 1, 2, 3, 4, 5, 6, 7. You get back 7. You add all those up, add 1 for that, and that's your answer. That's your 12. That's what this code says to do. For each thing in the folder, count it, accumulate it, and then return. So if I run this now, I find out I don't have a, I didn't change this from last, this is a new computer. So rats, what's it called? We'll just do this. Right, that's, I think it's user/ZACHA is what Windows 10 called it. Let's see. I'm going to comment these out for now. Gotta find something I know exists. What the heck? I'm getting a null point exception, line 33. Not my day. All right, anyone want to figure out what I'm doing wrong here?
Go to line 33.
Line 33 is it's just, it's calling list files. No, let's put a breakpoint and see what happens. Let's run it. We get here, FD is actually a file object. We step over, it comes down to here, it sets total to 0, and then it's going to go in and list the files. Well, sure. Okay. So I think what's happening is, it ran that time. We got the exception again. I think there's something corrupted about my file system somewhere deep down in there. Like there's a null stored. So, how am I going to save the day?
Pick a small file system.
I could pick a different file system. I'm just going to do this. Hope that works. So if FD happens to be null for some reason, yeah.
Is it possible that since you're looking on your whole hard drive, it could be like Stack Overflow?
I would get, if it was Stack Overflow, because I had to go too deep, there would be a different exception.
Line 37.
Is it possible it's accessing files it doesn't, or trying to access files it doesn't have access to?
Yeah, it's possible. Let's try this. All right, so if we try to list the files, we get null back. Let's see. It's running. I hear it. So, what's going on now? There's a lot of files to count. It's got to use the secondary memory to count them. So at least we know the program runs now without throwing an exception. There we go. 224,931 files on my hard drive. Except it's not a hard drive. It's a SSD. Okay? So we wrote a simple code and it just looked at the entire file system. And apparently, there are places where list files is returning null. Maybe it's because I don't have, it could be because I don't have access to it. In fact, maybe if I looked at the documentation, it would say that. Well, it talks about returning null. So I think something's gone haywire in there. So I had to put in code to deal with getting null back. Okay. So let's write another one here in the 5 minutes we have left. Yep, 5 minutes. How about this one here? Largest file size. So you can get the size of a file or a folder. The size of a folder is not the size of everything it contains. It's just, it stores references to the things it contains. So I want to get back the size of the largest thing that's contained. How am I going to do that? Yeah?
So kind of similar to the last loop.
Okay.
We can just have a variable that stores the maximum, and instead of like adding to the total, we check it's like the value against the maximum, and if it's greater, we change that to the maximum.
Okay. So it's yes, it's similar to the last loop. So I copied it. I'll leave in my little checks here that I used to bail me out. if FD is a file, I want to return the size of the largest thing in that file system. What is the size of the largest thing in that file system if the file system consists of a single document?
It'll be the size of that document.
It's going to be the size of FD. So I'll return FD.length. Okay? What kind of loop would I have down here now? It's an optimization loop. So we'll have largest so far. We'll let that be 0. And then when we're done, we'll return. Well, we'll see what we do. What do we do in the loop? What do we do for everything contained in FD? Right. We say if f dot length is greater than largest so far, return what? Not return. What do we do inside the if? Right. We say largest so far equals f dot length. So we found a new winner. The value that's returned by f dot length is a long. All right, and what do we return here at the end? You would say f dot length. You would say longest so far, but there's a slight problem. What have we not accounted for? What? Outside what scope?
Largest.
Largest. Yeah, we're not accounting for the folder itself, the original FD. So rather than have largest so far be 0, we'll have largest so far be FD.length. So we'll get the length of the folder. Then we'll look at everything. We'll find out about what will this recursive call tell us right here. I'm really being scatterbrained today. This is completely wrong. I don't care about f.length, do I? What do I care about? I care about the size of the largest thing contained by f. And I do that to make a recursive call.
Want it to be a long, right?
Yeah. Largest file size of f. And then I say if largest in f is greater than largest so far. I wasn't making the recursive call. So what I'm doing is, largest so far is the length of FD. And for everything it contains, I recursively determine the size of the largest thing it contains. And I take the largest of all. So if I run that, it'll still take a while. But that's okay. And we'll find out the size of the largest thing on my file system. Sorry about fumbling that. Are there any questions I could answer while my program runs? If I ask you to do this, which I will, where would you start? Suppose I ask you to do this one down here. Well, there we go. Oh, that's count file. Oh. Yeah. I didn't even run the method. So suppose I ask you to do this method right here. Report true or false. Is there a file that's at least so big? What's the first thing you would do to get started?
Largest is 0. You ran it off that directory that may not exist. You ran off the Zachary directory.
All right.
Zachary workspace.
Mine seems to be elsewhere. All right. Last question I'm going to ask. What did I do wrong? You are returning. right, suppose I ask you to implement this method down here. How would you get started? Where would you find your inspiration? Yeah?
The previous method?
Previous method. Take one of those previous methods, copy it in there. That gets you the structure. The structure needs to be if, ignore this crap here, if it's a document type of thing, that's the base case. Else, you've got to loop through everything the directory contains and make the recursive call on it, and then combine them somehow. All right, so my largest file is quite big. All right, we're done.
Six kids?
6.8 gigabytes.
10 to the 9. Yeah.